Let us discuss ScalarDB objects. In the previous chapter, we discussed some key advantages of ScalarDB. Let us take a brief review of the scenarios where ScalarDB provides an edge. ScalarDB provides an unified interface for different databases. It allows multiple types of databases to be treated as if they were a single database. You can manage siloed databases efficiently. Consider an example of microservice implementation using ScalarDB. ScalarDB also provides ACID functionality for non-ACID compliance databases such as NoSQL. In addition to that, it makes it possible to perform transactions between multiple types of databases, including NoSQL. Thus, it becomes easy to manage data consistency between departmental databases. ScalarDB supports transactions across multiple microservices. You can avoid implementing complicated compensating transactions. This simplifies application development across multiple microservices and also makes it extremely efficient. Now let us take an overview of various ScalarDB objects. This chart is a conceptual diagram of the objects managed by ScalarDB. The main objects are storage, namespace, table, partition, and record. Let us understand storage. Each database, such as RDB or NoSQL, is managed as storage on ScalarDB. Each storage is given a logical name, and developers access the actual database through the storage. The storage contains one or more namespaces, which in turn contain tables. ScalarDB supports having multiple namespaces within a single database, allowing you to manage different namespaces for different purposes. A table is a collection of data and is managed within a namespace. Multiple tables can be managed within a single namespace. A partition is a collection of records and is a logical unit of distribution to nodes. Therefore, records within the same partition are placed in the same logical location. A record or row is a set of columns that is uniquely identifiable among all of the other records. Let us understand how to access records with SQL. Consider an example. Select star from shopping.order or select star from point.history. In this case, shopping and point correspond to namespaces, and order and history refer to the tables managed within each namespace. This chart is a conceptual diagram showing the relationship between a storage and an actual database. The connection information of the actual database is mapped to the storage. In ScalarDB, the actual database is accessed through this storage name. Next, we look at the relationship between storage and namespaces. The simplest configuration is to manage a single namespace in a single storage. ScalarDB can manage multiple namespaces in a single storage or multiple namespaces in multiple storages. Next is the relationship between namespaces and tables. Within one namespace, multiple tables are managed. And within a table, multiple partitions and records are managed. There are two types of namespaces, managed by ScalarDB and managed by users. The coordinator namespace and ScalarDB namespace are managed by the ScalarDB system. Consider a coordinator namespace. It is used for recording the final state of transactions. There is only one coordinator namespace in one ScalarDB system. Consider a ScalarDB namespace. It manages table definitions of all the tables stored in the same database. It is created in each storage. The namespaces shopping and point are defined by users. User-defined tables are also managed inside it. The state table in the coordinator namespace maintains all the transaction states. The state is recorded as committed or aborted along with the transaction ID. This data is also used to recover the state of an interrupted transaction. When selecting a database to store coordinator namespace and its state table, you need to consider availability, performance, capacity. When the state table becomes unavailable, transactions cannot be executed on the entire ScalarDB. Hence, availability is an important factor. The availability of the state table can be increased by using a database with higher availability. If performance degradation or processing delays occur in the state table, transaction processing is delayed throughout ScalarDB. Therefore, select and configure a database by considering the expected transaction volume such as instance size and request units. As the number of transactions increases, the number of records in the state table also increases. Hence, it is necessary to consider the restrictions on storage capacity as well as expansion possibilities in required situations. The metadata table in the ScalarDB namespace manages both system and user table definitions. It is created in each database. The metadata table defines the column names, data types, and key types for full table name. The full table name is a combination of the namespace and a table name.